Alright, so let's talk science fair. This page is your milestone page. It is your timeline. These are your chunked parts of the science fair. In your packet that you received, there should be a date beside each of these things. Now, let's talk a little bit about what they are. The first milestone, you need to choose a project, a topic, an idea. You need to have an idea what your project is going to be, and then write a question. So maybe you observe that when you add an object to a container of water, the level of water rises. So then you might ask the question, what is the relationship between the physical characteristics of the object and the amount that the water rises? And so then you would write a hypothesis. Now your hypothesis, as we will see later, should be in the if-then format. That means you say something like, if an object is placed in water, then the water level will rise by the same quantity as the volume of the object. And now you have completed the first milestone. Now the second milestone is research your topic and use at least 2 sources. Now in this day and age, it's very easy to go online and Google things or go to Wikipedia. That's fine. But some of your sources need to be books. Okay? Go to the library. Look in your textbooks. Find a book to use that you can have you should have at least one source that is an actual physical paper book. Okay? And then write an informational paragraph. This paragraph is an intro to your research. This paragraph tells your teacher, hey, I've got my idea, I've got my hypothesis, I have done some research, and I am ready to move forward with my science fair project. The next milestone is to write a detailed step-by-step procedure for a controlled experiment. There's a few things here. One, it's detailed. You ever think about it? If you were to tell someone how to open a door, you don't just tell them, open the door. First of all, they've got to get to the door. And then they need to grab the doorknob, so they need to know where the doorknob is. And they need to turn it a certain direction, so they need to know that. They turn it clockwise or turn it counterclockwise. Is it a push door or a pull door? So they need to know all these steps. So we need a detailed step-by-step procedure for a controlled experiment. Now, let's look at that phrase, controlled experiment. Controlled experiment means you have parts of the experiment that you modify. This is your independent variable, and it is your experimental setup. Okay? So, again, if we're testing putting things in water to see how much the volume of the water increases by, then our independent variable is the volume of the object that we put in the container of water. That's our independent variable. The independent variable is what you, the scientist, change. Okay? And the experimental setup is where you change it. You also must have a control group. In the control group, you don't change anything. So in the control group, you do not change anything. So in this group, I might have a container of water, and I might have an object beside it, but I do not put the object in the water. Okay? So that's my control group. I'm not changing anything about it. Alright? Now, then it says, identify your control group and your variable. So that's what we just talked about. Our variable is the volume of the object that we put in the water. Our control group is the container of water that does not get anything added to it. Make a list of the items you need. So we need containers of water that allow us to measure. So we need graduated cylinders or beakers. We need objects that we know the volume of, or that we can easily find the volume of. We need water, and we might need some other measuring tools. If we have a wooden block, we need to measure the length, width, and height to find the volume. So you should list all these things so that you can have them ready to do your experiment. Then, lastly, we're going to create a data collection form. So this is going to be a table. It could be a spreadsheet where you are going to write your data. So in our experiment, you might have beaker 1 started with 100 milliliters of water, added a 5 milliliter object. Water went up 5 milliliters. Okay, so that's our data. Next, we have to perform the experiment. So this is going to be done at home. Okay. The experiment is done at home. When you come to school, you need to bring your data, and then you will write up your data. You will create your charts and graphs at school and turn those in, or a copy of them, as part of your grade. Okay, so you collect your data. Next, you need to analyze your data, create your charts and graph. So these will be done at school. Now, obviously, you may do some thinking about it at home. You may even do some analysis and start thinking about what kind of charts and what kind of graphs you're going to use. But you're going to put it all together at school, and because this is going to count for a grade, a mastery grade. All right, next step on our timeline, you're going to write a two-step conclusion. So step 1, you're going to answer the original question. Did the amount of water rise equal the volume of the container? Yes or no? Step 2, tell whether your hypothesis was supported or rejected and explain why. And that explain why is very important. Okay? Every answer is an answer. If you ever watch a crime show or read a crime novel like Sherlock Holmes, okay, they always start off with suspect A. And then they find out that it's not suspect A for some reason or another. So even though their hypothesis, suspect A did it, was proven wrong, that's still a result. They have still eliminated that person. So they move on to their next hypothesis. Okay? Now, so right or wrong is not what you need to think about. You need to think about why your hypothesis was correct or incorrect. If you can explain why it was incorrect, that is just as important as explaining why it was correct. Even a wrong answer or a wrong hypothesis still leads to a result that is useful if you write it and do it the correct way. Finally, you're going to create your display for your project. You should be doing this at least a week before January 29th when we have our science fair. It should be neat and easy to read. Organized, creative design. Don't put things all over in random places. You want a nice flow that someone can walk up and they can read from one part to the next part and tell what you did. But be creative with it. Put some color on it. Put some pictures on it. Your data charts, your graphs. Okay? Make it interesting. You can add pictures and graphics that relate to the project. Preferably, these will be pictures of your actual work, not just pictures of random people from the internet. Correct your spelling and grammar. Do this before you put it on the board. Okay? The class fair is going to be 122, and then the school fair is going to be 129. And then finally, the regional science fair is February 23rd. This is a Saturday. Right? So hopefully maybe that helps explain some of the things you need to do. Remember, with all of the milestones, you're going to do some of it at home, but when you come to school, your teacher is going to have you put it together in a final format that you're going to turn in, and that will be your grade. Okay, what you do in class. Okay, because we know what you do in class, and that's what we're going to grade. Is what we see you do in class. All right. So this is Mr. Furlow. This is video 1, and there's more to come. See you later.